confirm some.
Yes,
Yes,
it
it is
is.
visible.
So, welcome to Revit for Skyscrapers, Unpacking the Burj Khalifa Façade. Okay, so Monnier is a French B2B company, right? It consists of a lot of subsidiaries. One of them is Arcans, and we are here to represent Arcans. So, we have different companies in the Monnier group. We have Arcans, we have a Prolis, we have GCS, Energia, Ipso, and we also have a collaboration with CAT, that is Caterpillar. Monio Group was founded in 1906 and it has a more than 100-year rich history. It is a 3 billion euro revenue company that was there in 2023, and it in total it has a 279 million revenue. All over the world, we have more than 8,500 employees in the entire group, and we are present in almost 19 countries as of now. Arkan started its acquisition part in 2018, and from then they have been uh, acquiring one of, I'll say, the giants of the industry, and it has been a huge success. In 2023, we were a part of the Win Zero. We were acquired by Arkans, and now the whole group is present in the entire world. So if I talk about the industry focuses that we have, so we are in the engineering and construction, architecture, engineering and construction, the manufacturing industry, media and entertainment, education, we are there. In the government industry, we are there. The consulting services are there. We have a huge services portfolio that we have. We are also there in the graphics, arts, and computing, and we are also there in the hardware sales services, especially, right? So we have a very strong technical team in India itself. If I talk about, we have more than 150 technical resources in India, and there are more than 40 technical resources in US, EMEA, in the Australia's ANZ we have. So in total, we have almost more than 550 technical resources in the entire world. We are present in Americas, in the Europes, India, and the ANZ. Right. So that was a small introduction about the company. I am architect Vatsal Singhal. I am the program manager for services in the Arkhams group in India, right? And I myself I have Samar with me. So Samar is a senior BIM specialist over here and has great knowledge about BIM. So he'll be taking forward and he'll be explaining everything to you about the Burj Khalifa facade and how it can be made in Revit. Over to you, Samar.
Thank you so much, Vatsul, for that introduction. Welcome, everyone. It is great to have you all joined today for this webinar. All right, so today we'll be covering Revit for skyscrapers, unpacking the Burj Khalifa. We'll be going over some components of Revit, how we can use certain functionalities to create skyscrapers, and specifically we'll be discussing about the Burj Khalifa. So exploring the innovative techniques in Revit for creating precise and complex facade systems, enhancing architectural design and efficiency. So let's just go over the importance of facades in design. Facades enhance building performance. They are crucial in influencing the energy efficiency and overall building comfort. The well-designed facades also reduce energy consumption as well as operational costs. Aesthetic appeal also matters, so facades contribute to the visual impact and identity of a building. Advanced modeling techniques can be followed to create such structures. So utilizing Revit for facade modeling improves design accuracy and workflow efficiency. Complex facade systems exploration is also there. So in this session, we'll delve into modeling intricate facade designs for better outcomes. Okay, so what are a few facade system types? Let's just compare them. First are stick facades, which are made of vertical and horizontal framing members assembled on site, offering flexibility in design. Next, we have unitized facades, which are prefabricated panels that are assembled in a factory and can be done or with a quick installation on site. We also have custom facades, which are designed with unique materials, maybe some composites and unique methods as well, providing tailored solutions for specific projects. And finally, an iconic example is of the Burj Khalifa, which is a unitized facade system featuring sophisticated design and engineering. So there are some essential Revit tools that are used for facades. First is curtain walls. So whenever you are approaching a skyscraper facade, these are some of the functionalities that you need to be aware of in Revit. First is understanding curtain walls. So exploring the structure and function of curtain walls in Revit for effective design. Then we have components of curtain walls. So these are, once you've made a curtain wall, we have different components that we can edit and adjust according to our requirements. So we can learn about curtain grids, panels, mullions that shape the facade appearance. And we can also have a detailed look at curtain grids that define the layout of the facade design. Other essential tools include panels and mullions. So the usage of both of them, understanding their role and how they can, create a unique kind of a design. We have adaptive families in Revit as well. So adaptive families can be utilized to create versatile and dynamic facade elements. Apart from adaptive families, we also have pattern based families. So these are pattern based surfaces that can be followed. We can create pattern based families that can be then applied to divided surfaces. Today we'll be going over this in a short demonstration as well. So exploring parametric modeling techniques. First is creating reusable and flexible panels. So there will be techniques to design panels adaptive to various projects, enhancing efficiency and versatility. Dividing surfaces. So if you might know conceptual massing in Revit, you would know that we can divide a particular surface. Once we do that, we can easily use that divided surface to create complex forms. And finally, once we've used adaptive families, pattern based families, and done a divided surface, we can also control those patterns. So, strategies for managing and manipulating patterns within facade designs for aesthetic and functional benefits. All right, so let's just go over some key design features of the Burj Khalifa. The architects are Skidmore, Owings, and Merrill. It is at a height of 828 meters ASL in the metropolis of Dubai, and it is of course called the world's tallest building. It's a 162-story tower which combines local cultural influences with cutting-edge technology to achieve high performance in an extreme desert environment. The Y-shaped floor plan that we'll be looking at in a minute maximizes views of the Arabian Gulf. So it has been built of reinforced concrete and has been clad in glass. The tower is composed of sculpted volumes arranged around a central buttressed core. As the tower rises from a flat base, setbacks occur in an upward spiraling pattern, reducing the building's mass as it reaches skyward. At the pinnacle, the central core emerges and forms a spire. So let's just look at the description that I've given in a 3D view. You can see the central core is going up and creating a spire, and we have this mass which is reducing till we reach the top. So the design inspiration is a certain desert flower which was the main source of inspiration for the planning. The tower is composed of three elements arranged around a central core. So you can see in this plan that here is a central core and we have three different wings from which the tower has been created. The modular Y-shaped structure with setbacks along each of its three wings provide an inherently stable configuration for the structure and provides good floor plates for residential. Viewed from the base or the air, Burj Dubai is evocative of the onion domes also prevalent in Islamic architecture. These are some visual examples. So this is an aerial view. You can see the flower from which the plan was inspired. And this is a section comparing it to different buildings and towers throughout the world. And here you can see the particular 3D view. Now you can see this particular color coding that has been done, and you will be able to notice that these colors actually signify the variation in the mass and the built form as we move upwards. So this has the lower base has more mass, and this pink part is reduced. So this is the exact strategy I'll be explaining to you within the software on how we can achieve this in Revit. Before that, I would also like to talk a bit about other, topics or tips that you might have to remember, especially for designing such structures. So enhancing model performance in Revit is also a great feature. Model performance can be optimized. So implementing advanced techniques to enhance Revit model performance for facade projects. Once we've created a model, we can easily optimize it, do some analysis and see what is working and what is not working. We also have effective scheduling because each and every component of the building is divided into an informative item tag. What we can do is we can use effective scheduling to actually create a good timeline on which the project can follow. The importance of detailing is also very important, and Revit provides multiple annotation and documentation detailing features to do that for you. Techniques to enhance performance. Of course, once we've modeled the model, then we can use performance optimization to enhance the performance of our building. Impact of documentation. Again, if we've done the detailing, understanding how documentation impacts project workflow and overall facade design quality. Finally, we also have collaboration in facade projects. So fostering collaboration among teams to enhance the documentation and modeling of facades. This can be done through internal Revit based collaboration, or you could also use the Autodesk Cloud. So some more productivity tips. First is the utilization of keyboard shortcuts. This saves a lot of time rather than you going and graphically selecting the tool that you require. We can also leverage templates and families. So if your company is already working in Revit, you can use the templates and families they have been using on the company server and improve your workflow as well. And then, of course, we have effective project management. We have regular model coordination. So schedule regular coordination meetings to address issues and ensure team alignment on facade designs. Work sets for collaboration can also be utilized. So it's not just that one person has to work on the project, it can be shared throughout the team, and a good collaborative effort can be made for the project. Model performance can be optimized. You could also explore add-ins and plugins. So some great features or some creative features that you require, you could easily download plugins and add-ins to improve your Revit performance and workflow. You could also implement design reviews. This can be done again through cloud or through another BIM software called Navisworks. A clear documentation is also maintained within Revit. So once you set all the sheets, you can easily take those formats. If you've added whatever model changes you've made, they will be automatically updated and a clear documentation pathway will be laid out for you. And training of team members. So it is very important to invest in training sessions for team members to enhance their skills and knowledge in using Revit effectively. These were some tips to boost your Revit workflow. All right. So let me just now jump into the Revit software. And first, I will show you some basics of conceptual modeling. With those basics, you will be actually able to understand how we modeled the Burj Khalifa. Let's just start with a new file. This is my Revit environment. I hope it is visible. Yes. All right. I'll just open up a new project. in metric multidiscipline template. Yes. Now, my first point will be to create a twisted skyscraper using conceptual massing and demonstrate to you how you can easily convert that conceptual massing into a building. First and foremost, we will be giving levels. So let me go to my elevation. Let's say north elevation. I can turn off my crop region visibility, and I will turn off my scope box as well to uncheck my crop view. This I am doing in the properties tab, which is situated in the left hand side. On top is my command ribbon, which has all my commands. So commands according to the multi-disciplines that we have. And on the right, we have the project browser from where I can visit multiple views and sheets that I've created. All right. So right now we have L1 and L2 at a distance of 3600 mm. Let me just go to architecture tab, level, and create some levels. So 3600, and I am using the pick line tool to actually just click on the previous level to be able to create levels much easily. So like this, I can just go ahead and start creating multiple levels. As you might be able to see on my right that the project browser is automatically adding the levels. So floor plans are automatically being added. This is because I have checked this on my command ribbon, create plan view. So like this, we have easily created about 18 levels. I think that would be enough for this example. Now what I can do is I can navigate to my 3D view, which again I'll do on my project browser. So I'll go to 3D view, 3D, and you can already see these levels. And to now create a mass and actually begin modeling a skyscraper, I will go to massing and site. And here I will click on in place mass. Revit will just give me a warning that it has enabled the show mass mode, which we of course want. So I will just close it and I can just name my mass. So I will just name it to building 1. And you see we have some modeling settings available here. What I will do is I will select a rectangle tool and make sure my placement plane is level 1. Next, I could also model within my 3D environment, but for accuracy, I can navigate to L1, which is my level 1, and place a rectangle here. So about 31 meters by 31 meters is good. You can see I have placed this particular rectangle. Next, what I can do is I can easily, create more shapes on each of the level, or I could also copy this shape. So let me just go to copy and then I will click the paste drop down menu where I will select aligned to selected levels. By clicking this, I'll have this particular pop-up window which will ask me on which level I want to copy this rectangle to. So that would be level 18. And you see the rectangle has been copied to the top level. Now what I will do is I will also create another copy. So again going to my clipboard in my command ribbon and I will align to selected levels and I will create the copy on level 10. But for level 10, what I will do is I will actually use the rotate tool, which is in my command ribbon again. The shortcut for rotate is RO, and I will go ahead. Let me just select the rectangle first. I will click on RO and I will now just rotate this to 45 degrees. As you can see, I can enter the value of 45 and it will be rotated to 45 degrees. So here is a double rectangle that was created. I will just delete this one. And you see, now we have three simple basic shapes that I've created. And what I can do now is select each of this shape and go ahead and click on create form. There are two types of form, so solid form and void form. We currently need the solid form. So I will click on solid form, and as you can see, we have a very interesting geometry with us. Of course, when I'm modeling a building, I would follow the drawings and we would have a much more accurate building according to our requirements. But for now, let me just finish this mass. I clicked on the tick mark that was there on the command ribbon, and now you can see I have this mass ready with me. Okay, so this is a conceptual mass, something like the geometry that we create in SketchUp. Now, how do we actually convert this into a building? So this is a great feature that Revit has. What I can do is I can navigate to massing and site, and you can see I have all these settings with me under the model by face category. And very simply, I could choose whatever I want. So let's say first I want to create some floors. I will select the mass and then I will go to mass floors. So whenever you click on a mass, you will get this option. I'll select on mass floors, and then further I will select each and every floor. So I've checked all the floors and I will click on OK. What this will do is this will automatically create some mass floors according to the geometry that is there of the mass on each level. Next, I can go to model by face in massing and site and click on floor. Now, very simply, I can choose these mass floors to actually convert them into a floor. So you can see I have generic 300 floor family loaded. This is okay for now. And I could simply just select them all and click on create floor. Now you see that a certain thickness has been added to each of the level. Further, what I could do is I could also either add a wall or a curtain system. Both have similar functionality. So let's just go ahead with the curtain system. Clicking on curtain system in massing and site model by face, I will now start selecting the surfaces that I want to create the curtain system on. So those would be the four sides of this facade. And let's say I have selected this building. And what I can do now is maybe I could also change the settings. So curtain system, I have one family loaded. I could change the justification and offset of the grid 1 and grid 2. And now I will just click on create system. It will take a few seconds. And now you can see that Revit has actually converted that mass surface into a curtain system. So now you might see it hardly took me any time to actually create a very simple conceptual massing and convert it into a building. I can also press on tab to select multiple objects. So I could select one system panel, or I could select the entire mass, or I could also select the floor. Further on, we can easily go ahead, create the changes that we want, maybe change the curtain system and change the types of panels that we require. Let me just navigate to a level, and you can see we have this level with all the detailing in plan view as well. So this was a very basic introduction to advanced massing actually. And this I wanted to present particularly so that you can understand what we've done in the Burj Khalifa model. Let me just save this file. All right. So now let's just move on to another demonstration, which will be actually of creating a parametric surface and adding pattern based geometry into that surface. So again, I will go to new, create project. I will choose the metric template. All right. Again, I don't want this extends. This is a new feature that has been added in Revit 2025, which is quite convenient. But for this example, I do not require this. So I will turn this off using extends in my properties tab. And I will also delete these scope boxes. I will navigate to level 2. Here also I will repeat the same. Yeah. So that was one way of creating a mass. Let me now show you another way. I will again go to massing and site, in place mass, and just name the mass whatever I want. And now instead of using a rectangle or any other shape, I will actually use this point element. Point elements are quite useful. You'll understand now in just a few minutes. What I did is I just selected the point element and I have started placing these points onto my level 2. All right, so I have created a sort of a imperfect line. Let me just mirror this onto the other side. Mirror again, I'm using the command ribbon to select. And let me just create a middle as well. So this can be done precisely as well. Maybe I just want one point and then I could copy and use ortho to do a precise placement of these points. But right now for this example, we do not require that precise modeling. All right, so once we've placed these points, I will now connect them using the spline tool. And make sure that when we are connecting, I will actually just connect these particular lines vertically. So I've selected the left hand side. I will go ahead and click on spline through points. This will create a line for me. I will repeat this. So here and here as well. Let me just navigate to my 3D view. I could navigate using the project browser, or I could also go ahead, click on this house icon on top in the quick access bar and open up my 3D view. So yes, I've modeled it correctly. We have straight lines. Now, before actually converting this into a mass, I will also convert this into a reference line. That is actually useful because it converts the line into planes that we can further work on. So to convert this into a reference line, I will do nothing but just go to properties and click on reference line. So I just take the reference line and you can see two planes have been added on both of the ends. Similarly, I will do for the other lines. And now I can select all of these and go ahead and create a solid form. So if I had not made these into reference lines, these points wouldn't have been available to me to manipulate further. But now I can easily select one point and actually just manipulate their position at say Z axis and actually create something interesting. So let's say I want a complicated surface, something like this. All right. So I think this is enough for one example. Next, what I will do is I will select the surface. So how did I do that? I clicked on the edge of the surface and you can see here it says divide surface. For that, the shortcut is 2 times forward slash. So clicking on divide surface, it will actually use the surface geometry to divide it into a grid. But I will not stop here. I will also adjust the pattern of this surface. So right now, as it says on the left hand side in my properties tab, it says no pattern. What I will do is I will go ahead and I could choose any of the pattern that I want. But right now I will choose this triangle flat pattern. So you see the surface has been divided into triangles. We also have some other functionalities in my properties tab. So you can see the U grid and the V grid, which are the vertical and the horizontal axis for this surface. I will change this fixed number to, let's say, fixed distance, and I will change the V grid as well to fixed distance, and the distance I will provide as 900. Clicking on apply will actually change the surface for me. Now you see we have much smaller triangles going throughout the surface. So now I can easily click on finish mask and this has been created. But right now, this is again just a conceptual mask like we studied in the previous example, how to actually give it some 3D geometry. To do that, I will now create an adaptive family, an adaptive pattern based family. So let me just go to file, new, and I will click on family instead of project this time. Here I have my Revit library, which has a lot of templates that we can work on. But let me just navigate to metric instead of imperial. And here you can see we have door, we have furniture, but right now what we require is metric generic model pattern based. So this is what I will open and this will give me this particular template. Now to change the pattern of this template, I can simply click on this blue line grid, and on the left hand side, again, I will have the properties tab. Here I can go to my triangle, which I've used. And now you can see we have reference lines, we have points already placed with us, which are adaptive points. So adaptive points will basically adapt to whatever points that are there available on the surface. This is what makes this geometry adaptive. Let me now just create a 3D geometry using sweep tool. So for that, I will again use a point element. I will place this point element anywhere on my these green lines, which are my reference lines. So let's say I want to place it here, and you can see after selecting the point, I have a particular plane on which I can draw. On this plane, I will go ahead and choose rectangle and easily just draw a rectangle. Of course, precise dimensions can be followed once you're actually working on a project. And now what I will do is I will select this rectangle, and by holding on control, I will also select these reference lines. Next, I will go to create form and click on solid form. So what it did is you can see that it has created a frame for me. Similarly, what could be done is we could add maybe a glass panel between this. So I can choose maybe a surface, and this, how did I do this? I just selected the reference lines and created a form again. And for the material, I could go ahead, I selected this surface, going to my properties tab, I have material option. So here I can just use glass. All right, I think, yes, it has been selected. Now to actually take this particular family into my project, which is this surface project, first let me just save this file. So I will name it as if we have the project and the family open with us in Revit, what I can do is I can just click on load into project and it will show me the projects that I have open. So I will just click on project 2 and the family will be very easily imported into the project. So this is one way. The second way is maybe you can save the file and import it later using the insert tool. So now what I can do is I can go ahead, double click on the mask, then select the surface. Now going to my pattern, I can simply just choose, go to the drop down and choose this webinar family. So by clicking on this, it will take a few minutes, not minutes actually, I think 30-40 seconds to actually generate that webinar family onto my surface. Yes. So now you can see the particular geometry has been added to the surface. I can click on finish mask. And you see that we have a very parametric surface available to us. This can be used in roof structures or whatever kind of geometry you want. We also have some additional settings. So all these are covered extensively in the training sessions and courses that we undertake. So you can see right now I have border tile as partial. If I want this to be a complete and not, cutting this geometry, I could choose empty instead of partial, or I could also choose overhanging. So empty will actually just delete these edges and give me just clean rectangles, clean triangles. I'm so sorry. Yes. So you see, this was one example. Now, why did I show you these examples? This is because to make you understand and give you a bit of clarity that you can create masses of any skyscraper that you want, divide that surface, and then add whatever pattern based family that you require to create complex facades. This is right now horizontal, but of course the same thing can be done vertically as well. And a great comprehensive facade can be made. I'll just save this file as well. All right. So let's now get into the modeling of Burj Khalifa. I'll just navigate to a 3D file that I have opened. So this is the 3D model that has been developed within Revit. So as you can see, when I zoom in, that it has a curtain panel system all around. And of course, it follows the exact geometry and massing of the original building. And we also have different mass floors with us. So how did we approach this? This we approached using conceptual massing and then using model by face to convert that conceptual massing into a building geometry. Let me just break down and give you an example of how this can be approached. So first of all, what I did is I'll just navigate to my site plan and you can see I will just turn on yes. So I had imported this plan view and this is actually a typical plan view that consists the geometry of all floors within the Burj Khalifa. And you can see this is the top and this light blue is the base. Next, what I did is I actually used detail line, which is here in the annotation tab. So of course you have to first import this image, scale it according to the real scale of the building. And then further what we can do is we can use this detail line. The shortcut is DL to actually start tracing upon this. So let me just turn this off and show you. So this was the traced result, which I did on the site level. And you can see that this is exactly how the plan was. So it didn't take me much time because this was just tracing. Let me just navigate to annotate DL and you can see we have these drawing tools here. The most used tool on this particular plan was this curve. So start, end, radius, arc. This was used a lot to create this particular geometries. Next, there was one more feature that I used, which is I'm navigating to my architecture tab. which is reference plane. So what I did is I created three reference planes on an angle of 150 degrees. So these were three reference planes, and this one I just extended. And how I approached this was I just traced this particular part of the model. So the one which is highlighted in blue, I traced this. Then I used the mirror tool to mirror it on this side. And similarly, I rotated it and mirror it on this side because this is highly symmetric. So with this, I finished this particular geometry. Now the second part here, of course, I've skipped the basic parts, which is the setting of levels. So whenever you open a Revit file, it is important to set the levels. And of course, even for this, when I opened the file, I actually went ahead to give the levels. So I had imported a section view of the Burj Khalifa, and I had created multiple levels as per the section I had downloaded. So after doing this, I had all these floor plans available to me, and then I started to actually go ahead and use these geometries on my site plan to copy. So the command that I showed you, I have selected the geometry, I used copy, and then I used aligned to current view. So I just pasted it onto my top. Similarly, I used these lines to start copying on each of the levels. Let me just go ahead and show you. So level 17. So you see from the top till the level 17, we just have this spire which is there. So only two of these geometries were used. Then I went on level 15 and created this particular geometry. Then on level 12, I expanded it to this. Level 9, this. Of course, it took me a bit of time to understand and break down the geometry of the building. But once that was done, it actually became quite easy for me to use that site plan and keep on adding these lines. So it might be on your mind that why am I actually doing this? So once we've actually added these lines, the next part was to, let me just close these tabs. The next part was to create forms just like we did in conceptual massing and start extruding them. So one example for that can be that I can choose the top, then I could go to massing and site, in place mass, okay. And here I can use pick lines to use this particular circle. I can click on create form, and then you can see here I have this. So this particular geometry I then just extruded onto the level below. So this was, I think, a level 18. So I extended this to level 18. Then I navigated to level 18 and I made sure that I do not finish mass because all this is just one mass. That would actually help us to convert it into a building. Okay, I could navigate to level 16. I can extrude this as well to level 16. And you see, as I'm dragging it, it actually snaps to the particular levels. So this is one. Then I used pick lines again, clicked on tab to select all of these lines, and then again clicked on create form to have this geometry. This then I took over and extended it to the other level below it. And this was the top to bottom approach that I followed to actually just keep selecting these geometries and model my building. So this is level 14. I will again go to my 3D and I could do till this. So as you can see, slowly my form is being developed. So I used this particular method to actually achieve this mass. Let me just turn on the massing. So I'll go to massing and site, show mass. And now you can see I have this mass available with us. So the similar method I followed, going on each level and actually extruding it to the level below. This took a while because there were different levels. So let's say level 12, I extruded it to level 11 and so on. Next, I used mass floors to convert this into a mass, and then I added 162 more levels after I had done mass floors to create the stories, because these were different levels. These were height levels that were used for the section, but I created another set of levels, total of 168, and those I used to create the mass floors. And further on, let me just give you an example. I could either use massing and site curtain system, or I could also do architecture, wall, wall by face, and then go ahead and select exterior glazing on my properties tab, and then just pick face and start selecting all the faces. So hitting on tab, it selected all the faces for me. It will take a bit of time because this is a very large project. And what Revit is doing right now, it is converting all the faces of that mass into a curtain wall. So if you want to break this down into steps, the first would be importing plans, then would be setting the levels. Further would be tracing the plan. Next, keeping the plan and copying those geometries on different levels. Finally, using create form to create that mass, and next would be converting that mass into surface and mass floors. So in about 5 to 10 steps, you will be able to create a geometry something like this. So now you can see that it has converted all these faces into a curtain wall system. Further, we could detail it, detail the facade, adjust it however we want. Maybe we want to change anything in the curtain wall. I could go ahead, use this properties tab and change it according to my liking. So this is the final outcome. As you can see, the floors have been divided, the thickness of the floors have been given, and the mass has been converted into a facade. All right. I hope this breakdown was helpful, especially for the ones who already know Revit. They would have understood this better. All right. So, any questions?
So if you have any questions, you can just write it in the Q&A section that you have at the bottom, and we'll be happy to
Yes.
take those questions.
Meanwhile, when the question till the questions are being sent, let me just talk about BIM for design as well. I'm just sharing my screen.
For the recordings, yes, we'll be sharing the recordings with you, as well as it will be available on our YouTube channel. So you can just go to YouTube and search for Archons India Private Limited, and you'll be uh, finding a lot of other webinars too that are there on our YouTube channel, somewhat related to Revit or different products, I can say, and different technologies as well. So you can just go to YouTube and find them, and we'll also be sharing the Burj Khalifa facade with you, and also whatever Samar has shown today through various tools. We'll be sharing that as well on your email IDs. Yes, Samar, please go ahead.
Right. I think I'm having a bit of processing problem. This file is not
Wait,
loading, I think, because of the Revit.
I'll just share my screen. Just give me a minute.
Sure.
Okay. I hope my screen is visible.
Yes, it
Yes,
is.
it is visible.
Yes. Okay. So we'll be talking about BIM for design. So as Archons, we also have some professional courses that we run, and one of them is BIM for design. So it can be any project. We can help you to expertise in that. So we have been doing this from the past, I'll say 7 to 8 years, and it has been a very good solution for us. So why choose us? We have almost trained more than 5,000 students, pan entire world, not just in India. You'll be getting an LMS access for 1 year. We are the Autodesk Platinum partners, the only Platinum partner that is present globally for Autodesk, and because of that, we'll be giving you the original licenses to Autodesk till you work with us, till you are using the course. We also help you in the job assistance and tech powered architecture. So the scope of BIM, as everybody knows, has increased a lot in India. The smart cities, the DMRCs, and all the CPW buildings that have a mandate, any building that is above 30 crores need to be on BIM. So it is high time we as architects start adapting to BIM. We have experienced instructors. One of them is me. There is Afaq and there is Kulsum. We obviously have Samar, we have Kavya, and we have 5 to 8 more people who take these sessions, who have expertise in different domains. So we start from the introduction of Revit and we eventually end at the career assistance. So our Revit, or we say the BIM for design, is divided into three parts. It is the beginner, intermediate, and the advanced part. In the beginners, we help you to create working drawings of LOD 450. After that, we help you with families, schedules, adaptive families, right? Whatever Summer showed today, Massing is a part of that. Dynamo is there, Navisworks is there. So if I talk about the software, these are some software, and it is a 4 month course that has 150 hour plus of learning, right? Some of it, mainly, I'll say 80 to 90% of it is on Zoom, and we also have pre-recorded sessions for it. Our project typologies can be different from residential to commercials to hotels. You can also have your own project, and you can talk about that as well. We help you with two certificates. We have an Arcan certificate, which has the Autodesk Platinum Partner uh, logo on it, and we also have a Autodesk Training Center certificate, which again is issued by Autodesk with a secret number that is there. Some of our customers that are there in India are the biggest ones that you might have heard of. We have Hafiz Contractor, Burns and McDonald's, Jacobs is there, L&T is there, BIM Engineers is there, Sikkan Associates is there. Apart from that, we've also been working with Adani, Tata, and Reliance, all three groups. We also have academic alliances with Chitkara University and upcoming more to go we have. These are some of the reviews that we have had in past, and they've been excellent reviews. Some of them have been placed in some very big companies. So if you want to get in touch with us, I'll just share this with you and you can come back to us. If anybody is there from the MEP domain, we also have a MEP course that you can learn. If anybody who has already done BIM and understands BIM well, so we also have a course that you can go for, that is Dynamo, and you can take it up, and it will help you a lot in your future. So this is the module that we have. So I'll just share this as well in the chat box. Probably if I can. I think I can. Okay, so I've shared it. It is just being sent. Just a minute. So anybody who wants to work with us, like wants to get registered on the BIM for Design course, you can come back to us. We have a special discount to anybody who opts from this webinar. We the initially the course is for 80,000. We'll be giving you a 10,000 rupees discount, and it will then cost you for 70,000 if you have joined this webinar. You also have a Google the OneDrive form link, the Outlook form link. You can just fill that and you can reach out to us. Yes, Sama, you can please take over. You have some questions, I guess. So you can
Yes,
just.
I have some questions. Please feel free to chime in if you want to add anything. So first question is, can we give fabrication for glass and panels if we use massing? Yes, you could give fabrication, but that part would be done after you've converted that mass into a building. So like I used model by face, so you could use that and then do the fabrication or give glass detailing or panel detailing accordingly. So you actually created a structure in a horizontal plane. What triangular panel massing? How can we do that vertically, sir? Is by doing the same in the elevation view. Okay, so for this example, we would not actually require the vertical plane, but yes, definitely you can do massing in vertical plane as well. For that, I would recommend you to add either a reference plane or an object geometry and then use set work plane feature to select whatever plane you want to work at. So if it's a vertical plane, select a wall or a geometry or a reference plane to create vertically. Hi, Samar. Quite an insightful session. Thank you so much. Can we use automation in creating facades? Yes, we can definitely use automation. For automation, Dynamo plays a larger factor, and we could use this particular geometries that we've created, connect them with Dynamo, and use number sliders or other input parameters to create it parametric and automated as well. So maybe you could create a Python or a JavaScript to connect sensors to these particular geometries and have it behave accordingly. Can we have some details of plumbing pipes and drainage systems using BIM? Yes, there are multiple details that you'll be able to find. We have a specialized course for that called BIM for MEP. If you're interested, you could consider joining that as well. So it has a very similar format to which just like how Vatsal shared right now for BIM for design, and there we teach multiple factors and components functionalities for MEP design within Revit. सर आपने लाइंस ट्रेस की वो 2D लाइंस थी या 3D लाइंस बी जी आई थिंक 2D लाइंस इज नॉट विजिबल इन व्यू ओके yes, they were 2D lines. I used detail line, not model line. So detail line, which is DL, and they will not be visible in your 3D view because detail lines are actually an annotation category. They are just used for plan views and detailing. So they won't be visible. But once you are into conceptual mass creation, you will be able to pick those lines to create those forms. एंड 3D लाइंस की रिक्वायरमेंट नहीं थी, ये सिर्फ डिटेल लाइन से हमारा काम हुआ है. Does mass geometry convert to lines as masses are not recommended to be leave as it when handing over project? Yes, good question. Massing geometry does not convert to lines actually. The lines will still be there because it is a detail line. and we're just using pick lines. So what you can do is you can select and use the selection filter to select those lines, and if you want to you can delete or hide those lines, and also you can hide the mask, or I would recommend make a copy of that project, keep the mask, because sometimes one has to go back to the drawing board, adjust the geometry, and do revisions. So you can keep that mask, and for the final project file you delete that mask and just keep the detailed geometry with you. So they don't exactly convert to lines, the lines are still there, and those can be deleted or hidden. I hope I answered each and every of your questions. If there are any other questions, please send them. Anything you would like to add, Vatsal?
No, I think it was a really good session that we had. Guys, if anybody has any questions, we're open to take questions. We'll be here till 12:10. And if you have anything, you can just write it down in the Q&A and we'll be happy to take it up. Okay, so since we do not have any questions, thank you everybody for joining. We'll just end the session for today. Thank you. We'll have more upcoming webinars. We'll be sharing the link with you on LinkedIn and other platforms as well. Thank you.